In this example, we'll show you how to use Visual Job to create a dose test. In particular, we'll create a dose test array and we'll instance this into 4 quadrants of a wafer. And that will show how you can use arrays of arrays. Furthermore, we will include a dose label such that you can see after exposure and development exactly what dose each array element has been exposed at. One of the really strong points about Visual Job is that you have a graphical user interface where you can see your arrays, and Visual Job will create your SDF and DDF files for you with a single click of a button. For this dose test example, we'll use a simple lines and spaces pattern that I've previously exported to V30. We can just bring it in so we can see it. As you can see, it has already been proximity error corrected, and thus it has a dose modulation to it. When we make a dose test out of this, we'll create an array with different doses, and that means that this modulation table will be further modulated by the choices we make in our dose test array. In order to set it up, we don't need to have anything inside the viewer here. We simply start up Visual Job from this button up here. We will then go on to create a new job deck file. We will call it dose test. And this will launch Visual Job. This is the main window of Visual Job. We'll go straight to the substrate page. You'll notice that when you're on a wafer type, there is not too many choices here, and that is because most of the cassettes we have are multi-piece cassettes. So now you can choose between all the windows of the cassettes that you would usually be able to choose on the 9500 system. Now, we will be exposing a 2-inch wafer in this case, so I will use slot 2A. For my exposure, I will expect that this cassette will be loaded from slot number 9. And after exposure, I would like to load in cassette number 1. You can see there's a page for global mark positions. We're not doing any sort of alignment in this case, so we'll head straight to layer 1. This is where we can choose the calibration parameters, or in essence, which current we would like to expose at. We would like to expose at 4 nanoamps for this job. You can also choose the calibration path from this window. There's not that many filled into the system yet. If you would like to use a path that is not on this short list, you can click customize and then you can write the exact name of the path you want to use. The next thing we want to change is the shot pitch. If you're used to editing SDA files, you will know that the shot pitch is incremented in steps of 1/4 of a nanometer. And I know it says unit nanometer here, but this is not true. This is still in units of 1/4 of a nanometer. So if I want a pitch of 4 nanometers between my spots, then I need to enter 16 here. So 16 times 1/4 of a nanometer. It looks like the shot pitch is going to be 16 nanometers, but it's only going to be 16 quarters of a nanometer. I know that is slightly confusing. The next thing we want to change is the base dose. For the dose test that I want to set up, I want a minimum dose of 150 and a maximum dose of 250. So what I like to do is I would like to set up a base dose of 100. And that means in the next screen where we set up the modulation, I will use a minimum modulation of 1.5. So that is 1.5 times 100. And I'll set up a maximum modulation of 2.5. That way I'll get doses in between 150 and 250. With this entered, we will then head over to the arrays. This is where we define our arrays, and we will simply start by adding our chip array. So we click add array, and from the data to place we choose a chip, and then we can browse and we can find our V30 file. So this is our lines and spaces. We'll open this up. I would like to create 25 different doses. So I will do a 5x5 matrix with this design. You can see in the pitch, it suggests a number based on the bounding box of the design. I would like to pitch them a little bit further apart, so I'm going to go with 250 by 250 micrometers. I have a strong preference for always centering these things. There's a comment field. This is optional, of course. I like to name my arrays, especially if I'm working with many arrays, then it can be advantageous to name them something. So I will call this pattern array. The assign dose button, this is of course where you can actually assign doses to your different fields. In the assign dose, I always work on relative dose, and you can see my 25 fields right over here. They currently all have a multiplier of 1. We will of course like to change this. So we go down and we create a dose series. Now, as I said, I want my starting dose to be 150. My base dose is 100. So I put a start multiplier of 1.5. I want my end dose to be 250. And that means my end multiplier must be 2.5. With a base dose of 100, this will give me doses between 150 and 250. You can see how the array is populated over here, and it is per default in a meander increment. So we go increasing this way, go down, increase this way. I have a strong preference for changing this to raster, but that is of course entirely up to you. This way we get increasing doses always from left to right and line by line. Now with this selected, we can then go OK and OK. And with that, our array is created right in the center of our wafer. Now, as I said earlier, we would like to instance this out into 4 quadrants of the wafer such that we have 4 repetitions of this. We'll do that by creating an empty array, and then we'll instance our pattern array into this. So we'll add array, and data to place, we'll choose none, because initially we're not going to place anything into it. To fill out the 4 quadrants of the wafer, we choose a 2x2 array. And to space it out on a 2-inch wafer, we will step them 15 millimeters apart. And I always center my arrays. Now we click OK. And you can see now we have 4 empty arrays, or we have 1 empty array with 4 elements. Now the key to getting the pattern into these arrays is then to go down to the sub-array management. You'll notice over here each array has an ID, 1 and 2. So in the sub-array management, we can choose sub-array number 1, or we can choose the sub-array to be 1, and we can choose the parent array to be number 2. Now nothing happens right now, and that is because we need to explicitly say which of these 4 array elements our pattern array should be instanced into, and that we do in this field. And the syntax for doing this is to use a parenthesis and then a star to denote all elements, comma, all elements, parenthesis, end. And now we have then moved, or now we have instanced our pattern array into these 4 array items. What we would then also like to do is to add a dose label. Now this can be done from the text option. To begin with, I'll simply add a text that just says dose. Then you have to explicitly tell it what array to place this in. So we will place this in array number 1. And again, we explicitly have to tell which array elements to put this text string into. Now again, we would like to put this into all of the arrays. So we use the same syntax as before. Now, not much has happened, seemingly, and that's because the size of this text array is very, very little, very small. So we bump up the size to 20 micrometers. And now if we zoom in a little bit more, you can see it says dose in the middle of our pattern. That is not so useful yet. We still have 2 things to do. First up, we will move this out of the pattern and down here as a proper label. So we will simply introduce a negative 100 micrometer offset in Y. So now the dose label is in a good position, but currently it just says dose, so it doesn't do much good yet. So in order to get a dose inside this label, instead of just some letters, inside the $signs, you would write dose underscore rel, and this would then put the relative dose as the dose label. There's of course a problem with the accuracy. We can fix that by explicitly asking for 3 decimal points. So we add parenthesis 3. And now we have the precision to 3 decimal places. By default, this dose label will be exposed with the base dose, so that means 100, which, since we're doing the dose test, that could be too little. So I will explicitly tell which dose I want this one to be shot at. After the array positions, you can actually define the dose or the dose modulation, and we will modulate this with a factor of 2.5, which is the highest dose in our dose test. So you can't really see that much has happened, but if you turn on the dose tab, then you can see this one receives a higher dose than the rest of the pattern. So now we basically have everything ready. So we have our array with dose labels. We have it instanced into 4 pieces of the wafer. So now we're ready to press the generate button. When we press this one, wait a few seconds, Beamer will then generate our SDF and JDF files for this job. In this window, you get a small summary of what has happened. Now, the original V30 file has not changed in any way, but Beamer has generated a new V30 file. This one contains our dose labels. Then it has, of course, generated a JDF file and an SDF file. It has also generated a JDI file that has the dose modulation for the labels. Now, this one is also included in the main JDF file, so the JDI file is not really usable. Now let us go and open these files up so we can see what we got. So we got the JDF file and the SDF file, and we will open those in Super 80. Now, if you're used to working with SDF and JDF files, this will look very familiar to you. We of course asked to load cassette number 9, we asked to use slot 2A, we asked to beam at 4 nanoamps on aperture 4, we asked for a shot pitch of 16 quarters of a nanometer, we asked for a dose of 100. Now, if we look at the JDF file, a lot more stuff is going on. We have 3 arrays defined in this file. The first one is of course our main array, our 5x5 array of the dose pattern. As you can see, each of them has its own dose modulation table, and that's of course because it was a proximity error corrected design that we used in the first place, and now each array element needs to have another modulation dose based on the proximity error correction and the dose that we chose in the dose test setup. This array is then instanced into another array. This is the 2x2 array that displays the dose pattern onto the 4 quadrants of the wafer. The third array that's defined down here refers to pattern number 2, and pattern number 2 is our dose labels. So all in all, now we have all the files that we need to do our exposure job. And this has all been set up in Visual Job inside Beamer. I hope this gave you a little taste for what it can do for you, and that you will give it a try.